All right, here's a question for you. Is it possible for an equation to have more than one solution? Every equation we've dealt with before has had exactly one solution. Maybe the solution was 5, or maybe the solution was negative 2/3, but there's always one of them. Never 2, never 3, never 0. So, hey, let's see. Is it possible for an equation to have more than one solution? Why don't you take a moment to try to solve this following equation? Pause the video, give it a try, and see what happens. All right, so maybe something weird happened when you tried that. Here we go. So the first thing I think I'm going to do is I'm going to simplify the left-hand side, because before we do that, that's a good idea. So I'm going to distribute this 2. So we've got 2x plus 8 plus 5x equals 7x plus 9. I'm going to collect my like terms. 2x and 5x, we've got 7x plus 8 equals 7x plus 9. All right. Now, immediately, alarm bells are kind of going off here. I'm thinking, wait a second, this looks really weird. I mean, they look almost identical, but not quite. I'm going to even go one step further and continue with the motions, and I'm going to subtract 7x from both sides. I'll add negative 7x from both sides, right? In theory, you're trying to collect all of your unknowns on one side, and so maybe I'm trying to cancel these ones. But what we end up with is this statement then, right? Because these guys add to 0, these guys add to 0. We end up with the statement 8 equals 9. And we know that 8 definitely does not equal 9. So what does this mean? When you're going through an equation, going through the steps, and you end up with an obviously false statement like 8 equals 9 or 0 equals negative 7, it means that your original equation actually had no solutions. There is no number that you could ever substitute into this equation to make it true. It just has no solutions. So make sure to write that down. I'll say it one more time now. If you're going through solving a solution, if you're going through solving an equation and you end up with an obviously false statement, boom, your equation has no solutions. All right, let's take a look at another one. All right, another equation looks very similar from the previous one. Let's take a look. So, the only difference here is instead of 7x plus 9 on the right-hand side, now we have 7x plus 8. Let's see what happens this time. All right, so I'm going to go ahead and go through the motions per usual. All right, I'm going to go ahead and distribute that 2. So 2x plus 8 plus 5x equals 7x plus 8. All right, going to collect 2x and 5x. 7x plus 8 equals 7x plus 8. Whoa, 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 whoa. This also looks really weird. In fact, the left-hand side of the equation, that expression is exactly the same as the right-hand side of the expression. It means that these two right here originally were equivalent expressions because, look, they're equivalent expressions. What does that mean? I might even go as far as to say this is an obviously true statement. I mean, you could go ahead and continue through the motions. You could add negative 7x to both sides. You could add negative 8 to both sides. Eventually, you'd boil down to 0 equals 0, which I think we can agree that these are all obviously true statements. And when you are going through solving an equation, here's the note on the bottom. When you're going through solving an equation and you end up with an obviously true statement, it means that your equation has infinitely many solutions. And in this particular case, where we have just one variable, it means that all real numbers are solutions to this equation. I mean, it means any number you choose, anything in the world. If you substitute it in for x, you're going to get a true statement. All right, let's confirm that. Take a moment. And on the right-hand side here, I want you to first pause the video, and I want you to pick any number you want. And I want you to substitute it in for x and see if you get a true statement. Okay, I'm going to do the same. I'm going to substitute in a random number. I'm going to substitute in negative 7. All right, so 2 times negative 7 plus 4 plus 5 times negative 7. Is that equal to, question mark, is that equal to, I'm out of space, give me a moment here. Fantastic. Is that equal to 7 times negative 7 plus 8? Let's see, I'm going to go through this a little quickly. This is negative 3. 2 times negative 3 is negative 6. Negative 6 minus 35 is negative 41. Is that equal to negative 49 plus 8? That is negative 41. Holy cow, look at that. Wow. So I just randomly chose negative 7, and it worked. And I hope that whatever number you chose, it worked as well. So the takeaway from this again is if you're solving an equation and you end up with an obviously true statement, like 0 equals 0 or 7x plus 8 equals 7x plus 8, boom, infinitely many solutions. And if you're dealing with just one variable, all real numbers. All right, last little bit. So now the question becomes, well, we know that it's possible to have no solutions. We know that it's possible to have one solution. We know that it's possible to have infinitely many solutions. When is this going to happen? So we've got two equations down here, equation A and equation B, and one of them is going to have just one solution, just like normal like we're doing. And one of them is going to have either no solutions or infinitely many solutions, some kind of crazy situation. Can you tell just by looking without actually solving them which one is going to have exactly one solution? Okay, now maybe you have to go through and actually solve them, but one thing I'm noticing here in equation A and equation B, note that they're both simplified on both sides of the equation. That's important. It's a lot easier to tell when they're totally simplified. In equation A, I see 4x and 4x. I know that when I add negative 4x to both sides of the equation, I'm going to have 0 x's left. I'm going to have no x's. And I'm going to have a statement involving just constants. And that statement is either going to be obviously true or it's going to be obviously false. In this particular case, we end up with a statement negative 7 equals 9, which is definitely false. So we would say no solutions to this equation. Right? You would write that down. You let your reader know there are no solutions. And if there are infinitely many solutions, you're right. Infinitely many solutions. Or you also maybe in this case, right? All real numbers. You got to let your reader know that. On the right, I see that the coefficients on our x variables are different. Right? I've got 4x and a 2x. So no matter which side of the equation I collect my unknowns, I know that I'm going to have some of them left. I don't really care. I'm not going to have none of them left. Right? So maybe I'll add negative 2x to both sides. I get 2x minus 7 equals 9. And then from there, I don't really care what happens. I know I'm going to get a solution for x. In this case, it happens to be 8. The point is not that it's 8. The point is that we got something because our coefficient, when we collected all our unknowns on one side, our coefficient wasn't 0. Okay, so just another interesting scenario that might happen when solving these sorts of equations.